Alright, hello everybody. Today we're going to finish off talking about the different types of chemical bonds by talking about the second and third types of bonds, which are metallic and covalent bonds. Okay, we started out talking about ionic. These are the other two. Should be a relatively short one, so let's just go ahead and get started. So, first of all, metallic bonding. Okay, this is a bond that occurs within metal elements. Alright, so if you have a chunk of metal, this is the type of bond that's holding it together. Just a reminder that metal alloys are mixtures, not compounds. So when we talk about metallic bonding, we're talking about the bonds between atoms of the same element. We're not going to be talking about something where aluminum is bonding to copper or gold is bonding to silver. We're talking about gold bonding to gold or aluminum bonding to aluminum. It's just one atom bonding to other atoms of the same element. Okay, so what it actually looks like inside a metal is what we have in this picture here. We've got a bunch of nuclei. Those are marked with the positive sort of bubbles there, in a kind of crystalline structure, meaning that it's kind of regular. And then there's a bunch of delocalized electrons that are just kind of floating around and kind of being shared between all of the other atoms. Okay? And basically what this does is, the positive nuclei are going to be repelling one another. That sort of forces them into this shape because they're kind of being, this center nucleus here is kind of being repelled on all sides, so it kind of has to stay in the center, right? And this shape is three-dimensional as well. But they're all kind of stuck together by being attracted to all the electrons that are in between them. They kind of shield each other from the charge from the other nuclei. So in this way, the electrons kind of act like a glue and kind of stick these nuclei together in this crystalline pattern and give it a structure, okay? But these properties do kind of cause metals to act in unique ways. Okay, first of all, metals are very good conductors of electricity, and that might make sense to you because electricity, if you know this, is basically explained by the flow of electrons through a substance, okay? And these delocalized electrons, because they're not necessarily attached to any particular nucleus, are able to move in more or less any direction pretty much freely. Okay, and so that allows electricity, aka electrons, to flow through a metal very well. Also, the fact that there's not necessarily like bonds of a certain length connecting all of these nuclei together, they're able to kind of be smushed in various ways without breaking or causing a tear in whatever the material is. And that manifests in the way that metals are ductile and malleable. So that's ductile and malleable, these two words here. Basically, that ductile means that you can take an element and pull it, or you can take a substance and pull it without breaking it. Okay? Rubber would be, well, actually, rubber's not a good example because it's elastic. Some plastics would be a good example where you can pull them and to the point where they're very thin and then let it go and it won't snap back, it'll just stay pulled out. Metals can do that too. And malleable is kind of the same thing, except you're able to pound it into different shapes. Okay, so basically metals, you're able to change their shape because of this sort of unique bonding style. And metals are also strong because, like I said, every nucleus in here is attracted by a bunch of different electrons and repelled by a bunch of different protons, and so it's very hard to kind of take one of these nuclei and kind of pull it out of a metal substance, for example. Okay, and we'll talk about this in the next lecture, but there's no formula for a metallic compound. When you're talking about a metal, you just write or say the name of the metal itself. So if we're talking about aluminum, aluminum makes metallic bonds with itself, and we would just write aluminum as, Al, or gold as AU, or something like that. Alright? And that's basically all we need to know about metallic bonds. Remember, the three things we need to know about bonds are: how are they formed? In this case, that's the stuff about the electron C and the glue. What type of elements make them? So metals for metallic bonds. And being able to write the formulas for them. And in this case, it's very easy because you're just writing the name of the element and there's no subscripts or anything. Okay, next up, the last type of bond is covalent bonds. So we've had ionic, which is between a metal and a nonmetal. We've had metal bonds, which is between a metal and itself. And then finally covalent bonds, which is between two nonmetals. Okay. Covalent bonds occur when two nonmetals share one or more of their valence electrons. So let me just briefly explain how this differs from ionic bonds. So for an ionic bond, we had something like this, where sodium had this one extra valence electron, and chlorine had 1, 2, 3, 4, 5, 6, 7 valence electrons, and because of the octet rule, remember, it wanted to have 8, and so sodium sort of gave up its valence electron to chlorine so it could have a nice stable outer shell, and so sodium could not have this one not very stable electron hanging around. And then, because of this negative charge and positive charge, these two got attracted to one another, and that forms the ionic bond. For a covalent bond, we've got something like hydrogen and another hydrogen. So hydrogen is like sodium in that it has one valence electron, and covalent bonds, the difference is that instead of one thing giving its electron to another, they each share one electron to make the bond. Okay? Because for sort of reasons we're not going to get into in this class, electrons like to be in pairs. Okay? And so this bond, which is sort of written in shorthand as just a line connecting the two, actually has two electrons in it that are paired together and are thus sort of more stable than when they're by themselves. Okay, there are other these bonds can also double or triple themselves, basically, in which case it would have 4 electrons or 6 electrons in the case of a triple bond. I'll give an example of that later. But yeah, this is the main difference, is that they share electrons instead of donating electrons, which is an ionic bond. Okay, so here are the examples. So diatomic elements, that's basically like what I did with hydrogen. Chlorine chlorine has 7 valence electrons, and they like to pair up, like I said, and so 6 of them will pair up with themselves all nicely, but then one of them isn't paired, and so the way it sort of solves this is it pairs it with another chlorine atom that has 7 valence electrons, and then these two pair up. Okay, so you get this single bond between chlorine. Nitrogen is also a diatomic element, and it makes a triple bond with itself. Okay, and so it does this it has 5 valence electrons, and so it has 2 that bond that pair up with each other, and then it's got these 3 that are sort of lonely, and then it's got another nitrogen with 1 pair of valence electrons. So these pair, and these pair, and it makes a triple bond. Alright, the mechanisms by which you need to figure this out or be able to draw these, don't necessarily have to worry about that, but just recognize that if you have, these are called Lewis structures. Lewis structures. If you see these are covalent bonds. That's basically what you need to know. Water, another example, that's an oxygen, which remember it has 1, 2, 3, 4, 5, 6 valence electrons. So we get 2 hydrogens, each with 1, and then boom, pair them up, and so we get this shape right here for oxygen. Carbon dioxide, same deal. Carbon has 1, 2, 3, 4 valence electrons, none of them paired up. And oxygen has 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And so we get bonds here, and I drew it kind of badly, but bonds here, and so there's a double bond on both sides in this case, and so you get this sort of linear, this linear molecule. I erased them, but linear molecule is like this. Alright, so those are your examples. Basically, once again, the things you need to know about covalent bonds are: how are they made? They're made by sharing electrons. What makes them? 2 nonmetals. And how do you write out the formulas? And that will be done in the next lecture mostly, but basically you account for, there's no charge balancing you need to do. You just, in the actual formula itself, you just write a subscript for how many of them there are in that molecule. Okay, but we'll talk about that more in the nomenclature lecture. Okay, that is all I have for you about covalent and metallic bonding, and I will see you in class.